The first sign came not as a discovery, but as a disturbance in silence. In late October of 2025, the deep space observatories that watch the sun's perimeter began to detect something faint, a slow, deliberate flicker near the star's corona. It was subtle at first, like a candle's breath on the horizon of a cosmic ocean, but within days, the faint glow became a flare, and then an eruption of blue-white light so intense that software alarms triggered across the network of solar telescopes orbiting Earth. An object small, cold, and impossibly distant just months before had suddenly ignited. They named it 3I Atlas, the third confirmed interstellar object ever recorded. It had traveled billions of years through the galactic dark, a wanderer between suns, and now, as it brushed past our own, it did something no model could predict. It exploded at perihelion. Not in violence, not in fragmentation, but in light, its brightness doubling in hours, its spectral fingerprint shifting toward the blue. Astronomers across continents paused, staring at data that defied every expectation. This was not how comets behaved. For as long as humankind has looked upward, the heavens have appeared as a silent stage of repetition. Stars rise, burn, fade, planets turn, comets visit, then retreat to their frozen prisons. Yet 3I Atlas arrived like a trespasser from another script, a messenger written in an alphabet we barely recognize. It came from beyond our heliosphere, beyond the warmth of the sun's breath, carrying in its core the memory of another sky. As it neared the sun, the object brightened as expected at first, driven by the sublimation of volatile ices. But then something changed. The increase accelerated an exponential curve without reason. Within a span of days, its luminosity had surged twice beyond predictive models. Its composition appeared to shift, its glow deepening to a hue bluer than the solar spectrum itself. In the sterile printouts of spectroscopic data, scientists saw the unmistakable fingerprints of carbon molecules C2, NH2 signs of intense ice sublimation. But even that could not explain the violence of the surge. It was as if 3I Atlas had crossed an invisible threshold, something like a boundary between restraint and revelation. Instruments recorded a mass loss rate of water vapor nearly 40 times what it had been a month earlier, 5.7 times 10 to the power of 28 molecules every second, a torrent of matter screaming into space. The numbers spoke of energy that should not exist, of ice that should not burn. Telescopes trained toward the sun's blazing limb captured the event. The Solar and Heliospheric Observatory, Stereo A, and the GOES 19 satellite all caught glimpses of the interstellar wanderer as it flared near perihelion. In those frames, the comet appeared as an elongated ghost, not spherical like familiar comets, but stretched, diffuse, trembling. And most strange of all, it bore no tail, no plume of dust trailing behind it, no telltale arc of particles scattering sunlight. Just a lone, radiant form without ornament, suspended in the firestorm of solar radiation. For astronomers like Qichang Zhang of Lulin Observatory and Carl Battams of the US Naval Research Laboratory, the data were unsettling. Comets were supposed to follow rules. They heated, they outgassed, they brightened in predictable rhythms. But 3I Atlas, this emissary from another star, was rewriting those laws in real time. In the language of science, anomalies are invitations. Every contradiction to theory is a door left ajar. Yet there was something haunting about this one, because unlike anything born within our solar system, this object carried no shared history with the Sunday. It came from a place untouched by our familiar physics, from an ecosystem of chemistry that may have died before our world began. And now, against all probability, It was reacting to our star with an intensity that bordered on fury. To the untrained eye, it was just a brightening speck lost in solar glare. But to those who understood what they were seeing, it was an ancient relic, screaming in light, a message written in the language of energy, incomprehensible and yet deliberate. Something changed, one researcher whispered as the numbers streamed in. Something woke up. Theorists raced to interpret it. Some spoke of volatile pockets collapsing, of cryogenic explosions triggered by internal pressure. Others suggested that cosmic rays, accumulated over eons, had altered its chemistry so profoundly that its surface now behaved like a reactor when exposed to sunlight. Still, others hesitated to speak at all, wary of what speculation might imply. For in that moment, 3I Atlas was not just an object, it was a mirror. In its inexplicable behavior, it reflected the limits of human understanding. How fragile our models appeared beside this interstellar visitor, a thing born under another sun, now unraveling its mysteries before us. The explosion at Perihelion was brief, lasting mere hours, yet it left behind data that will occupy scientists for years. In those few moments, humanity witnessed something older than its own history flare into existence within reach of our instruments, then begin its slow retreat into the dark. The cosmos had delivered a visitor, and that visitor had spoken in light, in silence, in defiance of everything we thought we knew. In the weeks before the explosion, the object had already drawn attention from a small cadre of astronomers scanning the sun's surroundings for sun-grazing comets. Among them were Chi-Chung Jiang of Lulin Observatory in Taiwan and Carl Battams of the US Naval Research Laboratory, two veterans of the coronagraphic watch. Their instruments, designed to study solar flares and coronal mass ejections, sometimes caught far smaller dramas, icebound visitors brushing too close to the furnace. Most disintegrated quietly. But on the digital screens in late October 2025, one faint point of light behaved differently. At first, the object's recorded brightness increased gently, following the predictable curve of a comet approaching perihelion. Then it began to deviate. Each day's photometric reading rose more steeply than the one before, until the slope became exponential. Jiang recalibrated his data, thinking a sensor fault had caused the surge. It had not. Battams, examining the same object through NASA's SOHO and Stereo A coronagraphs, confirmed the impossible. The newcomer had doubled its brightness in half the expected time. Official logs would later mark this moment as the birth of a mystery. The observatories had been tracking 3I Atlas, a designation indicating its interstellar origin, the third object of its kind ever confirmed, after Oumuamua and 2I Borisov. Unlike any of the millions of comets bound to the Sun, it was a guest from another star, cutting through the heliosphere on a path that could never repeat. Its journey, reconstructed from velocity data, suggested a velocity of over 130000 miles per hour, fast enough to escape the gravitational pull of any star it passed, a pure transient, a messenger that would never return. On Earth, night by night, astronomers compared notes through the cold hum of online observatory channels. Someone noticed a subtle spectral shift towards shorter wavelengths blue light, where there should have been yellow-white. Another researcher correlated the rise in brightness with a surge in water vapor emission. The comet, if that was still the right word, was losing an estimated 5.7 times 10 to the power of 28 molecules of H2O per second, 40 times its rate only a month earlier. To visualize that number was to imagine a glacier the size of a city evaporating each second into the void. Yet the instruments showed something even stranger. There was almost no dust. Normally, when sunlight warms a comet, jets of vapor carry solid grains into space. forming the luminous tail that painters and poets have adored for centuries. But in the coronagraph images of 3I Atlas, there was only a hazy spindle, an elongated aura with no tail, no trail of particulate matter to catch the light. It was a ghost, leaving no trace of itself behind. Jiang recalled thinking, if this is a comet, it is one that has forgotten how to be a comet. Batham's preliminary report to NASA's Solar Physics Division echoed the sentiment in drier language, observed morphology inconsistent with standard sublimation models. In simpler words, the data made no sense. Still, the observers continued. The GOES-19 satellite, newly equipped with a refined solar imager, captured sequences of the object shimmering like a pulse between frames. Instruments meant to detect solar storms now tracked a fragment of alien geology. Scientists debated whether to treat it as a comet, an asteroid, or a new category entirely. A term began to circulate in late-night emails: interstellar transient. For every observer, there was an undercurrent of emotion they did not write into their logs, a mixture of awe and unease. To witness something that has traveled through the galaxy for billions of years is to stand at the edge of human scale. 3I Atlas was older than the Sun, older than Earth's oceans, and yet, here it was, reacting violently to a star that had never touched it before. Somewhere in the thin hours of morning, as fresh telemetry arrived, Jiang compared the shape of the light curve to those of ordinary comets and realized the difference was qualitative, not quantitative. It wasn't just brighter, it was behaving differently, as though driven by physics unaccounted for. This isn't acceleration, he said quietly to a colleague. It's awakening. The phrase spread through the astronomy channels, half serious, half in jest. But in retrospect, it captured the mood precisely. Something ancient and silent had crossed a boundary and responded as if to a call. It was as though the warmth of the sun had reached deep into its frozen heart and found something waiting there. Over the following days, the collaboration expanded. Spectroscopic instruments on the Swift telescope confirmed the unusual emission bands of carbon dimers, C2, and amidogen, NH2. These molecules glowed in the ultraviolet with an intensity out of proportion to the visible light, giving the object its uncanny azure hue. Teams at ESA and JAXA joined in, sharing data through encrypted networks. Everyone agreed the numbers were real, the explosion was real, but the cause remained hidden. For Bathams, accustomed to cataloguing thousands of ordinary sungrazers, this was a personal turning point. He later remarked, "It's as if you've been watching sparks for 20 years and then one of them speaks." His words, poetic yet plain, encapsulated the astonishment shared by many. Across observatories and universities, hypotheses bloomed. Some pointed to internal caverns of frozen gases collapsing under heat. Others imagined an insulating crust suddenly rupturing, allowing solar radiation to pierce the nucleus. A few invoked more radical ideas, unknown compounds that react explosively when transitioning from interstellar cold to solar warmth. Each theory felt provisional, each contradicted by some fragment of the data. Still, the investigation had begun. A discovery that started as a faint blip near the sun had now become a riddle for the entire scientific world. The object's unpredictable flare was a challenge written across the firmament. Explain me, or admit you cannot. And beneath every technical discussion, beneath every chart and measurement, there was something else, a quiet reverence. Because beyond all its strangeness, 3I Atlas was also beautiful. In its wild surge of light, it reminded humanity that the universe still holds surprises grand enough to make even seasoned scientists stop, stare, and wonder if perhaps the cosmos itself was watching back. By the time the world's telescopes had synchronized their gaze, the mystery of 3I Atlas had evolved from curiosity to contradiction. The numbers simply did not belong to the same physics that governed ordinary comets. A familiar rule had been broken and broken openly, as if to remind scientists that nature still holds dominion over their confidence. In the standard model of cometary behavior, sublimation drives a predictable rhythm. As sunlight warms the surface, frozen volatiles like water, carbon monoxide, and carbon dioxide vaporize, venting jets that push outward and cause a slow brightening. The mathematics of it are elegant, almost musical, each increase in solar flux mirrored by a corresponding rise in luminosity. But what 3I Atlas did at Perihelion defied that music. When Jiang and Battams plotted the data, they found the curve refused to settle into the smooth arc of a typical comet. Instead, it leapt, doubled, then fractured into smaller spikes, flashes of energy, like a heartbeat gone erratic. In less than a week, the object's water emission rate had surged 40-fold. Telescopic readings suggested it was ejecting 5 quintillion tons of vapor per day, a torrent so vast that, if focused, could empty Earth's oceans in less than a millennium. Something deep inside had ruptured. But what mechanism could explain such abrupt violence? Comets are fragile things, snowballs held together by gravity's gentlest touch. When they flare, it is usually the quiet drama of heat melting ice. Yet 3I Atlas was not melting, it was detonating in slow motion. Scientists described it as a fire hose on full blast, its nucleus venting with impossible force, as though something beneath the surface had reached critical pressure. The first hypothesis was simple collapse. The object's structure, weakened by billions of years in deep space, might have cracked under solar heating, but that should have produced visible fragmentation, chunks of the nucleus tumbling through the coma, scattering dust into space. Instead, the object remained intact, an unbroken shard burning brighter than ever. The second hypothesis invoked chemistry. Perhaps exotic compounds, ices laced with supervolatile molecules like hydrogen cyanide or methane, had lain dormant under an insulating crust. As the crust eroded, these ices would have flashed into gas, accelerating sublimation in a runaway reaction. Yet, even this could not explain the color. The spectrum had shifted decisively toward blue, an unnatural hue for a comet whose dust typically scatters sunlight into warm golds and whites. The data pointed to C, 2 swan bands, and NH2 radicals, products of intense photodissociation. But the ratios were off, too concentrated, too pure. It was as if the surface chemistry had been stripped of everything except carbon and nitrogen. When astronomers overlaid these readings against known comets Halley, Encke, Neowise, the differences were shocking. None shared the same spectral gradient. None emitted such concentrated carbon signals. It was as if 380 LAS were a distillation of the galaxy itself, a sample brewed in another star's furnace. The strangeness deepened when the team compared the data to the object's velocity. At over 130,000 miles per hour relative to the Sun, the heating rate should have been limited by the brief time spent near Perihelion. Yet the object behaved as though it had been simmering for months, its activity building toward a precise crescendo exactly as it crossed the solar threshold. "Everything about it feels intentional," murmured one researcher during a late-night data call. The words hung in the air, half metaphor, half unease. For physicists steeped in the precision of natural law, that suggestion was uncomfortable. To call something intentional in space is to imply purpose, and purpose is a concept belonging to biology, not astronomy. Yet 3I Atlas was beginning to blur those categories. At NASA's Goddard Space Flight Center, teams revisited archival data from August and September, long before the explosion. Subtle irregularities emerged, minute flickers in reflected sunlight that hinted at surface modulation. Perhaps, they thought, the object possessed fissures that opened and closed with rotation, exposing hidden ice in rhythmic intervals. But no rotational period fit the pattern. The flicker was erratic, not periodic. It was then that researchers began to invoke a term that had all but disappeared from modern astrophysics: paradigm violation. Not because the event contradicted specific equations, but because it resisted explanation altogether. The comet was too bright for its distance, too active for its mass, too blue for its chemistry, too stable for its violence. Publicly, the scientific community was cautious. Press releases described anomalous brightening behavior and non-standard gas composition. But privately, a sense of wonder and fear was spreading. For centuries, humanity had sought visitors from beyond the stars. Now one had arrived, and it behaved as if the stars themselves had forgotten their rules. Meanwhile, astronomers debated the implications of its blue light. Blue meant energy shorter wavelengths, higher photon excitation. The glow wasn't merely reflective, it was emissive, radiating like a plasma under stress. Some compared it to auroral emissions, where charged particles strike atmospheric gases to produce light. Could the comet's own magnetic field be interacting with the solar wind in a way unseen before? Could its nucleus be conducting electricity? To test this, space physicists modeled the magnetic environment around the object. The results were inconclusive but tantalizing. Perturbations in the plasma sheath around 3I Atlas hinted at organized structures, vortices, filaments, regions of compression. No natural comet had ever exhibited such patterns so close to the Sunday. In conferences, slides filled with equations and uncertainty. The object's eruption defied every predictive code, every thermal model, every expectation. It was as if a silent visitor from the deep had looked upon our star, felt its warmth for the first time in billions of years, and answered with a gesture both violent and beautiful. The scientific shock was total. Within a single week, 3I Atlas had transformed from a faint interstellar drifter into a phenomenon that unsettled the foundations of cometary physics. It was, quite literally, something new under the Sunday. And as humanity watched, through orbiting lenses and radio dishes humming in deserts and mountaintops, one realization began to crystallize. The cosmos is not finished with its surprises. Even now, amid the mapped and measured heavens, there are still events that can make the equations tremble. When the brightness subsided into a steady gleam, astronomers expected to see the familiar signature of dust, those tiny grains that trail behind every comet, scattering sunlight into a gossamer plume. But as the data streamed in from the solar observatories, something was missing. There was no tail. The coronagraphs aboard SOHO, Stereo A, and GOES 19, capable of imaging faint material even against the sun's glare, showed only an elongated blur, a faint, spindle-shaped body of light, diffuse and strangely symmetrical. No dust jets, no particulate fan, just a column of gas suspended like a whisper near the solar corona. It was as if 3I Atlas had shed its body and left behind only its breath. To the scientists who study comets, that absence was almost as shocking as the explosion itself. Dust is the comet's defining act. It tells of rocky skeletons beneath the ice, of collisions, fractures, the relic rubble of planetary birth. Without dust, a comet becomes something else, something undefined. At Lulin Observatory, Jiang compared the high-resolution frames from October 29th with those captured 2 weeks earlier. The earlier image had shown faint speckles consistent with dust scattering. The later image showed none. Somewhere between, the tail had vanished completely. Battams proposed a working hypothesis. Perhaps the comet's composition was almost purely volatile ice and gas with very little solid residue. If so, the sublimation could release immense amounts of vapor, but almost no dust. It would glow brilliantly for a time, but never form the iconic tail. Others countered that even gas jets should carry grains, at least microscopic ones, yet the instruments were blind to any particulate reflection. The data seemed to mock the language scientists used to describe it. They still called it a comet, but only out of habit. Comets have tails. 3I Atlas had none. Meanwhile, spectra from the Swift Ultraviolet Optical Telescope confirmed the presence of hydroxyl OH emission, a clear indicator of water vapor. The object was venting moisture in extraordinary quantities, creating a halo of ionized gas visible even through the glare of the solar corona. But where dust should have accompanied it, there was only emptiness. The contradiction deepened. Normally, comets near the Sun display two distinct tails, a curved one of dust and a straight, blue one of ionized gas. Here, only the gas tail remained thin, short, and almost vertical. It was a comet stripped of its ornaments, pared down to essence. Jiang wrote in his field notes, "The morphology is unlike any comet in recorded observation, a ghostly elongation, featureless yet luminous. Its absence is its message." At the European Southern Observatory, a team ran light-scattering models to explain the missing dust. They proposed an intriguing idea, that 3I Atlas's surface had been coated in carbon dioxide frost, which for months before perihelion had insulated the nucleus, keeping deeper water ice frozen. When that CO2 layer finally sublimated, the protective barrier vanished, exposing fresh ice directly to solar radiation. The result was a runaway cascade of water vaporization and explosion of gas without solid debris. In other words, the comet's silence in dust was itself a symptom of catastrophe. Its skin had boiled away, leaving only vapor. But another, quieter theory began to circulate. What if the object's nucleus was fundamentally alien, composed not of rock and ice as we know them, but of exotic carbon compounds that vaporize cleanly, leaving no particulate trace? This was no longer speculation but necessity. Nothing in known cometary physics could account for a total absence of dust. To pursue the question, researchers turned to the James Webb Space Telescope. Its infrared spectrograph had observed 3I Atlas in August, months before the perihelion event. The readings revealed an unusually high concentration of carbon dioxide and carbon monoxide, much higher than in any comet native to our solar system. Even stranger, the chemical ratios suggested that the outer layers had been transformed by long exposure to high-energy cosmic rays. This radiation, striking the surface for billions of years, had rearranged molecular bonds, creating a crust of carbon-rich material unlike anything seen before. In essence, the comet had become encased in a shell of its own history, a fossilized memory of interstellar space. Computer simulations indicated that cosmic rays could penetrate up to 50 to 65 feet into an object like 3I Atlas, altering its chemistry, making it harder, darker, more resistant to thermal erosion. Such a crust would act as armor, protecting the nucleus until it neared a star. Then, once the protective carbon dioxide layer sublimated, sunlight would strike that ancient irradiated shell directly, and the reaction would be violent. That might explain the explosive brightening, but it did not explain the form. Why the elongated shape? Why the absence of rotation-induced jets? Why the eerie symmetry? The simplest answer was that we were witnessing not a spherical comet, but a fragment, a splinter from some larger parent body ejected long ago from another system. Its structure, stretched by tidal forces and cosmic impacts, might have become a spindle over billions of years. When sunlight hit its long axis, the sublimation could produce the uniform outgassing that made it appear smooth, tailless, and static. Yet, even that model failed to capture its strangeness, for this was an object that had traveled through the interstellar void for perhaps 7 or 8 billion years older than our Sun, older than any planet in this system. During that exile, it had been sculpted not by warmth and wind, but by the silence between stars. What it had become was something no human had ever seen, a relic of cosmic erosion, a survivor of unthinkable time. Astronomers began to speak of it with reverence. It was no longer just 3I Atlas. It was the ghost comet, a thing of gas without body, light without dust, a presence that defied categorization. In the endless noise of data and telemetry, one idea persisted that perhaps this absence was not a flaw, but a message. The missing tail, the blueness, the smoothness, all spoke of transformation, matter remade by cosmic time. This was not the birth of a comet, it was its afterlife. What we were seeing, said one theorist, was a memory of a world that no longer exists. And as telescopes tracked the ghostly traveler moving deeper into the solar glare, humanity stared into the image of an object that had crossed billions of years only to dissolve in a single gesture of light. The dustless silence it left behind was its final paradox, a comet that shone brighter for having nothing left to shed. The deeper the scientists dug into the mystery, the clearer it became that 3I Atlas was not a passive victim of sunlight. Something within it had shifted, a threshold reached, a balance undone. The prevailing hypothesis, cautious yet compelling, began to take shape around one crucial detail: the carbon dioxide that had once cloaked the object like frost. Months before perihelion, 3I Atlas had been a faint, cold traveler, its surface likely sheathed in CO2 ice that insulated the deeper layers from solar radiation. This thin veneer of volatile gas acted like a shield, preventing the underlying water ice from awakening too soon. Astronomers theorized that as the comet approached the inner solar system, this carbon dioxide sublimated gradually, creating a tenuous atmosphere that slowed further heating. But then, in late October, that fragile equilibrium shattered. When the last of the CO2 layer evaporated, sunlight struck the nucleus directly for the first time in eons. Beneath the frost lay pockets of pristine water ice, untouched since the dawn of another star system. Now they faced the sun's full intensity, and the reaction was instantaneous. Vast reserves of vapor erupted through fissures, releasing gas at rates so extreme that the object's brightness surged 40-fold. It was as though the comet had been holding its breath for billions of years, and at perihelion it finally exhaled. This interpretation soothed part of the mystery. It explained the explosion, the blue glow of ionized water molecules, even the absence of dust if the deeper layers were mostly pure ice. But it also invited deeper questions. Why had the CO2 layer persisted for so long? Why was the transition so abrupt, as if triggered by an unseen mechanism rather than a gradual slope of temperature? At NASA's Goddard Space Flight Center, thermal modeling teams ran thousands of simulations. Most failed. The temperature gradient required for such an eruption was narrow, too precise to occur naturally, without some structural anomaly guiding it. The event had not been chaotic, it had been exact. Meanwhile, the James Webb Space Telescope's infrared data hinted at something even stranger. The crust of 3I Atlas appeared layered, alternating bands of density and reflectivity, like sediment in stone. Each layer recorded a chapter of cosmic history: exposure to interstellar radiation, collisions with micrometeoroids, perhaps even chemical reactions driven by the galaxy's background energy. Over billions of years, This layering had hardened the surface into a kind of ceramic dense enough to trap volatile gases beneath. When the CO2 shield vanished, those gases found release through microfractures, jets, carving invisible fissures across the nucleus. The resulting pressure built until the object became its own pressure vessel, a cold volcano waiting for the Sunday. And yet the eruption's geometry was too symmetrical. The gas burst evenly across the body, not from localized vents or cracks. That uniformity bothered the researchers. In physics, symmetry is rare. It hints at design, or at least at laws not yet written. One group at the Royal Belgian Institute for Space Astronomy proposed an elegant solution: cosmic rays. Over billions of years, the continuous bombardment of high-energy particles could have altered the material uniformly throughout the outer shell, creating an evenly irradiated crust with similar porosity everywhere. When heated, the entire layer failed at once, releasing trapped gases in unison, a global exhalation. It was poetic in its way. The universe had sculpted a perfect pressure system through time and radiation alone, only to unleash it in a single incandescent sigh. But for others, that explanation carried discomfort. Cosmic ray damage should have weakened the crust, not strengthened it. For it to maintain cohesion through billions of years of radiation, impacts, and thermal shock, it must have possessed extraordinary structural resilience, something more like fused glass than porous ice. A few voices at conferences dared to ask, could interstellar chemistry produce self-stabilizing materials unknown in our system? Compounds formed under alien stellar conditions, where different isotopic ratios, pressures, and magnetic fields prevailed. In this context, 3I Atlas became more than a comet. It was a sample of another universe's workshop, a geological embassy from a place humanity would never visit. In one remarkable exchange during a private symposium, a planetary chemist from JPL remarked, "This isn't a frozen relic, it's a record. It's the diary of another solar system, written in the language of ice." Still, that diary was written in riddles. Why did its brightness surge precisely when the CO2 depletion reached zero? Why not earlier? Why not later? What mechanism dictated the exact timing of the event? That precision gnawed at observers like Batoms. "You don't get exact triggers in natural systems," he said to a colleague. "You get ranges. This thing switched on like it was waiting for the Sunday." Of course, no one meant that literally, yet the metaphor refused to leave the discussion. The event's timing, its cleanliness, its perfection, all hinted at a deeper mechanism, perhaps not conscious, but complex enough to border on deliberate. Theorists soon expanded the model. Beneath the irradiated crust might lie a layer of amorphous ice glass-like, metastable. When heated past a critical temperature, it would suddenly crystallize, releasing latent heat and volatile gases trapped within. This phase transition could create a self-reinforcing feedback loop, explaining both the timing and the intensity. The phenomenon had been observed in laboratory settings with simulated comet materials, but never on such a colossal scale. Here, it unfolded across an object possibly tens of kilometers wide, a slow-motion detonation powered by sunlight and time. As the days passed, 3I Atlas stabilized. The outgassing slowed, its brightness plateaued. But the impression it left on the scientific community lingered, that nature, even when governed by familiar equations, could still find ways to imitate precision, to mimic intent. And perhaps that was the deeper message hidden in this frozen traveler's outburst. It reminded humanity that design and accident are not opposites in the universe, they are partners in the same cosmic dance. Sometimes, the laws of physics can choreograph an event so perfect, so sudden, so exquisitely timed, that it feels like a choice. The CO2 shield had broken, the buried ices had awakened, the comet had breathed, and for a moment the sun itself seemed to listen. It was around this time that the first realization struck the researchers with quiet, shattering awe. 3I Atlas did not belong here. Every curve of its orbit, every isotope signature whispered the same truth: it was not one of ours. Born beneath another star, it had wandered for billions of years through the dark interstellar gulf, carrying within its nucleus the chemical memory of a sun that no longer shone. Its atoms bore the fingerprints of a foreign nursery: different metallic ratios, altered isotopic balances, traces of compounds never seen in the icy bodies of our solar system. This was not just an object, it was evidence of a place we could never visit. When the first compositional data from the James Webb Space Telescope arrived, astronomers could hardly contain their fascination. Webb's near-infrared spectrograph showed unexpected molecular ratios: carbon dioxide dominating far beyond normal levels, methane nearly absent, ammonia scarce. Even the presence of oxygen-bearing compounds defied the usual proportions found in comets of our system. The chemistry spoke of an origin under a cooler, redder star, perhaps one poorer in heavy elements. "Imagine a comet built in a different periodic table," one spectroscopist said. "Everything familiar, yet rearranged." Its birthplace, then, may have been a long-dead dwarf star in the outer Milky Way. There, under faint sunlight and in slower time, molecules had frozen into patterns alien to ours. Over billions of years, gravitational encounters could have ejected the nascent body into the void, set adrift on a trajectory that would carry it through lightless space for longer than Earth has existed. And now, after an eternity of silence, it had come close enough for us to witness its unveiling. To trace its past, astronomers rewound its orbit through computer simulations. The path extended backward through the interstellar medium, a line that crossed no known stellar neighborhoods in recent galactic history. If its estimated age of 7 to 12 billion years was correct, then its parent star had likely already evolved into a white dwarf or faded into darkness. The home that birthed it was gone. What reached us, then, was a relic, a survivor from a chapter of the galaxy we can no longer reconstruct. This revelation transformed the tone of the investigation. What had begun as a study of physics was now a study of ancestry. Every molecule escaping from 3I Atlas carried a story of stellar alchemy older than the Sunday. Its carbon dioxide had once been carbon forged in the heart of a supernova. Its oxygen had been born from the first breath of an ancient star. Its ice was not water in the simple sense, but a fossil of cosmic birth. Scientists began to describe it as a message in chemistry. The object's volatile gases were not mere emissions, they were language. The ratios of isotopes, the concentrations of carbon compounds, even the gradients of radiation damage, all could tell us how and where this thing had formed. In that sense, 3I Atlas was not just an interstellar traveler, but a storyteller, whispering of alien conditions that once existed light years away. But there was something unsettling in its structure too. Unlike most comets, which are conglomerates of dust and ice loosely held together, 3I Atlas seemed remarkably cohesive. Its nucleus behaved as a single, monolithic body. Observations showed little fragmentation despite the enormous pressure from its outburst. It was as if the object had been compacted, fused under conditions far more intense than any comet in our system could endure. Some suggested it might have formed closer to its original star, where heat and radiation were stronger. Others speculated about cosmic ray compaction over time, a slow metamorphosis under the constant rain of high-energy particles in deep space. Radiation could have melted and refrozen the outer layers, welding them into a hardened crust. Inside, volatile ices might have remained untouched, preserved in perfect darkness for eons. The paradox deepened, a fragile traveler that was somehow indestructible. At the Royal Belgian Institute for Space Astronomy, researcher Roma Maggiolo described it poignantly. "The interstellar environment does not preserve, it transforms," he wrote. "What we see in 3I Atlas is not the original composition of its birth world, it is the fossil of the journey itself." His team's computer models supported the idea that cosmic rays had penetrated 50 to 65 feet deep into the comet's body, creating what they called a radiation-forged shell. This crust was not merely protective, it was alchemical. Under eons of bombardment, simple molecules had rearranged into complex organic structures, long carbon chains, nitriles, and other compounds that hint at prebiotic chemistry. In other words, 3I Atlas might carry within it the same molecular seeds that lead to life, but from a completely different star. That possibility shook the community, because if even one such object could travel intact between star systems, it meant that life's chemistry is not confined to local suns. The galaxy itself becomes a carrier, a vast courier system for biological potential. Panspermia, once a fringe speculation, suddenly looked less like fantasy and more like inevitability. As Webb's sensors continued to dissect its light, astronomers were confronted with a philosophical vertigo. The gases escaping from the object were not merely vapor, they were heritage. Each molecule was an emissary from a forgotten sun, a microscopic envoy of another dawn. And as those molecules dispersed into the solar wind, they mingled with our own interplanetary dust, joining the endless exchange of material between worlds. For a brief moment, the chemistry of two star systems intertwined. It is easy, in the sterile language of science, to forget the poetry of such events. But beneath the data and equations, 3 Atlas was a story of encounter, between the ancient and the new, between one world and another, between the finite and the infinite. It reminded us that we live not in isolation, but in communion, that every atom in our bodies once belonged to other stars, and now, perhaps, to other travelers. The object's behavior, its strangeness, its refusal to fit our models, all of it became a mirror to our own ignorance. And so, humanity watched this foreign relic not just as a scientific subject, but as something sacred. It was a survivor of time beyond measure, carrying within its frozen heart the signature of a cosmos that has long forgotten its name. For the first time in living memory, we were not merely studying a comet. We were listening to the voice of another Sunday. When the first spectral reconstructions from the James Webb Space Telescope reached the desks of cosmochemists, a new revelation bloomed. 3I Atlas carried scars, not fractures or impact marks, but invisible wounds etched into its substance by time itself. Billions of years of exposure to galactic cosmic rays had changed it at the molecular level. Every surface grain had been struck, again and again, by subatomic bullets, protons, helium nuclei, high-energy ions hurled from supernovae and pulsars. Over aeons, that bombardment had restructured its matter, rewriting the crystalline order of its ice into something tougher, darker, alien. This was not erosion, it was metamorphosis. According to Roma Maggiolo's team at the Royal Belgian Institute for Space Astronomy, cosmic rays had penetrated an estimated 50 to 65 feet deep into the object's crust, forming what they termed an irradiated shell, a fusion of organic residue, carbon monoxide ice, and chemically mutated silicates. Beneath that hardened skin lay the untouched memory of its original world, locked away like a secret that only sunlight could one day awaken. But the process of irradiation had done more than scar it. It had remade it. Computer simulations showed that under constant exposure, carbon monoxide molecules were transmuted into carbon dioxide, nitrogen into cyanides, and complex hydrocarbons into dense tar-like polymers. Over time, These layers absorbed ultraviolet radiation and cosmic dust, darkening until they became almost metallic in sheen. What Maggiolo described, poetically, as a crust of time itself. When sunlight finally reached this surface near Perihelion, the object did not behave like pristine ice. It reacted like armor suddenly shocked by heat after a billion-year winter. Parts of the crust fractured. Gases beneath it found channels of escape. The result was that explosive brightening, the geysers of vapor, the dazzling blue of ionized molecules escaping at speeds of kilometers per second. In simpler terms, the object had been cooked by the universe. The discovery stunned researchers. It meant that what they were studying was not the original material of a foreign solar system, but a hybrid, a relic that had spent most of its existence being remade by cosmic radiation. They had hoped to read its composition like a fossil, but now they saw only a palimpsest, its original writing buried beneath the edits of deep space. Maggiolo phrased it poignantly, 3I Atlas is no longer the product of its birth star, it is the child of its journey. That line spread through the astronomical community like a whisper of poetry, a reminder that even objects beyond imagination are still at the mercy of time. The implications were profound. For decades, scientists had dreamed of studying interstellar objects to glimpse the conditions in distant star systems. But if the interstellar medium could so completely transform a body, then the universe itself was rewriting the evidence. Every visitor we receive is not a sample of another world, it is a survivor of its voyage. The cosmic ray crust also raised practical questions about the nature of interstellar matter. Could such a hardened shell explain the object's strange resilience, its refusal to fragment under intense heating? The answer seemed to be yes. The simulation suggested that radiation could forge a layer dense enough to endure impacts and extreme temperature shifts without cracking. That would also explain the smooth, elongated appearance observed in coronagraph images. And yet, there was beauty hidden in this harshness. The irradiated material emitted faint near-infrared glows when struck by sunlight, a quiet luminescence that made the object shimmer with ghostly silver hues in Webb's detectors. To some, it looked as though 3I Atlas was still smouldering from its long exposure to the cosmos, its skin remembering every star it had passed. In the laboratories of planetary chemistry, samples of simulated irradiated ice were bombarded with particle beams to reproduce what the comet had endured. The results were humbling. Under sufficient radiation, water ice could indeed turn opaque, brittle, and chemically rich, producing exotic compounds such as formamide and methanol, precursors to amino acids, which meant that while cosmic rays had destroyed the object's pristine surface, they had also enriched it with molecules capable of life. Suddenly, the story of 3I Atlas was not just a physical one, it was biological. For billions of years, it had drifted through the interstellar dark, gathering these compounds in silence, becoming a kind of chemical crucible adrift between suns. If such objects were common, and many astronomers believed they were, then the seeds of life were not confined to planets. They were passengers, carried within these ancient travelers, waiting for moments of warmth to reawaken them. In the poetic language of cosmology, the galaxy itself became a gardener, scattering frozen seeds from star to star, from age to age. But among scientists, this realization sparked discomfort too, because if cosmic rays had transformed the object this profoundly, then there was no such thing as an untouched interstellar sample. Every visitor we meet will have been rewritten by the journey. And perhaps, in a deeper sense, that is the rule of the universe. Everything changes in motion. Still, the revelation gave meaning to 3I Atlas's defiance. It was not breaking the laws of physics, it was demonstrating them in their most ancient form. Entropy, chemistry, time all conspiring to make something strange, yet inevitable. Its blue light was no longer a mystery. It was a confession. The glow of carbon molecules, energized by the same radiation that had sculpted its crust, radiating the story of its own creation. As Webb continued to monitor the fading afterglow, the data confirmed what intuition had already whispered. This was no comet in the ordinary sense. It was a relic forged in radiation, tempered by eternity, and now briefly illuminated by the fire of another Sunday. A messenger that had crossed the galaxy to remind us that even in the coldest places, change never ceases, that nothing, once born, remains untouched by time. If the outer layers of 3I Atlas were the diary of its journey, then beneath them, somewhere deep inside, lay its original voice, the untouched memory of a world that once circled another star. For all the analysis, all the data, all the light curves and spectra, the central question remained the same: what lies beneath? For astronomers, this question was not metaphorical. Beneath that 50-foot irradiated shell, there might exist matter unaltered since the object's birth, a pocket of pristine chemistry that could reveal the elemental ratios of an alien Sunday. To reach it would be like opening a time capsule from a forgotten corner of the galaxy. But nature offered no easy key. As 3I Atlas swept past the sun and began its outbound arc, every instrument turned to its radio telescopes, listening for thermal echoes, spectrographs straining to read the faint light reflected from its retreating surface. The hope was simple yet profound, that the sun's fierce radiation had stripped away enough of the crust to expose the untouched layers beneath. If cosmic rays had indeed carved the shell through billions of years, then solar heating might now be undoing that work, vaporizing the outer polymers and laying bare the uncorrupted core. It was the only chance humanity would ever have to glimpse what truly lay inside before the visitor slipped forever back into interstellar night. But what would that core contain? Some speculated it would resemble the hearts of ordinary comets, dirty snowballs of ice and dust, primitive but familiar. Others dared to imagine something stranger. The chemistry of its outgassing already suggested molecular complexity rare even among the most active comets. What if, deep inside, the nucleus-preserved compounds formed under conditions entirely foreign to our physics, ammonium salts, metallic ices, crystalline structures shaped in alien gravity? Still, others extended the speculation further. What if that core was not simply different, but organized its layers arranged by processes we do not yet understand? The idea skirted the boundary between science and imagination, yet it persisted, because everything about 3I Atlas seemed to exist at that boundary. When Avi Loeb of Harvard learned that NASA had not yet released the full spectroscopic dataset, he filed a formal request for transparency. His reasoning was as pragmatic as it was philosophical. "We are witnessing material that predates our sun," he said. "That information belongs to everyone." His words resonated because the data did feel communal, cosmic in a sense. Every photon emitted by that object carried a message from a time before the Earth had oceans, before life had a name. The hidden interior of 3I Atlas was no longer just a subject of astrophysics. It had become a symbol, a metaphor for all the mysteries buried beneath the surfaces of our understanding. The irradiated crust was human ignorance, the untouched core, the truth we may never reach. Meanwhile, the James Webb Space Telescope continued to record the faint infrared glow from the comet's receding form. The signals hinted at slight changes in reflectivity, perhaps signs that some of the dark crust had indeed peeled away, revealing brighter material beneath. But the readings were ambiguous. At this distance, data became whispers. At the European Space Agency's data center in Darmstadt, analysts pored over each frame, comparing before and after signatures. "If the crust thins," one noted, the albedo should rise. Even a few percent would mean exposure of deeper layers. Another scientist nodded but frowned. And yet, if that happens, we'll never know what caused it, the sun or something within. The thought lingered, or something within. That phrase haunted late-night meetings, the kind that stretch past midnight when fatigue makes imagination bolder. For beneath the veneer of professional restraint, many wondered if the interior of 3I Atlas was more than passive. Some of its behaviors, the precise timing of the explosion, the symmetry of its outgassing seemed almost deliberate, not mechanical perhaps, but patterned. Could internal stratification, built layer upon layer over eons, produce such precision naturally? Or was there a guiding principle hidden in its design, a self-regulating mechanism sculpted by unknown physics? To those who refused to indulge speculation, the answer remained purely thermodynamic. The core, they said, was likely composed of amorphous ice, rich in trapped gases. When heated, this ice would transition to a crystalline state, releasing energy and producing the explosive effects observed. Simple, predictable, ordinary. But the simplicity was deceptive, because that same process, scaled across a body several kilometers wide, operating under interstellar conditions, could produce outcomes that seem anything but ordinary. It could create oscillations, bursts, even repeating outflows that mimic intention. In the language of physics, this is known as self-organization, order born from chaos, complexity emerging from simplicity. Perhaps that is what the interior of 3I Atlas represented, not a secret crafted by intelligence, but a secret authored by nature itself, whose laws are older, wilder, and subtler than our minds can comfortably grasp. As November turned to December, telescopes on Earth finally caught sight of the departing comet in the pre-dawn sky. To the naked eye, it was barely a smudge, a faint, elongated shimmer fading with each day. But to those who had studied it, that ghostly light carried the weight of all their questions. The sun had burned its outer mask away. Whatever was hidden beneath was now exposed to the cold once more. Whether it revealed the memory of another star or the bones of a mystery deeper still, humanity would likely never know. The object was moving outward now, climbing the invisible slope of its trajectory, bound once again for the dark between stars. Yet it left something behind, a fragment of understanding, a whisper that knowledge and wonder are not opposites but companions. The deeper we dig into the unknown, the more we find that the universe resists final answers, offering instead endless layers of revelation. And perhaps that is what truly lay beneath the crust of 3I Atlas. Not pristine ice or exotic chemistry, but the eternal reminder that every discovery, however complete, conceals another waiting in the dark. The day of Perihelion passed, but the shock it delivered continued to echo through observatories and laboratories around the world. Every instrument that had eyes on the sun during those hours captured something humanity had never seen before, a comet that exploded not in fragments, but in light. When 3I Atlas reached its closest approach to the sun, it should have peaked and faded gently, following the familiar bell curve of heating and cooling that dictates a comet's life cycle. Instead, its luminosity surged again, as though reigniting. Within hours, the brightness had doubled a second time. Observers scrambled to recalibrate, thinking their sensors had malfunctioned. They had not. The interstellar visitor was blazing with renewed intensity, defying thermodynamic reason. Radio arrays tuned to its coordinates detected a sudden increase in hydrogen line emissions, while ultraviolet instruments aboard NASA's Swift telescope registered an overwhelming flood of hydroxyl radiation, the unmistakable spectral sign of water molecules torn apart by sunlight. The object was shedding water faster than any comet ever recorded, more than 40 times the theoretical limit calculated for its mass. This was not a surface event, it was a systemic one. Something inside the nucleus was feeding the eruption. The European Space Agency's Solar and Heliospheric Observatory reported a secondary anomaly. As the brightness climbed, the shape of the object's coma, the faint glow surrounding the nucleus, shifted from circular to elongated, then back again. It pulsed, almost rhythmically. Plasma physicists speculated that interactions between the comet's magnetic field and the solar wind could be producing the shape oscillations, like ripples on the skin of an invisible drum. But no one could explain why the effect was so perfectly timed with the outburst. At first, astronomers proposed a structural collapse, perhaps. The crust had cracked, exposing deep ice pockets that vented explosively. Yet, post-perihelion imaging revealed no fragmentation. The nucleus remained whole, intact, serene in the aftermath of its own eruption. This was not destruction, it was transformation. The sheer precision of the event unsettled scientists. The eruption had occurred exactly at perihelion, within minutes of the object's closest solar pass. That timing was improbable even by cosmic accident. Natural processes rarely obey clocks. They drift, vary, and blur into probability. 3I Atlas had not drifted. It had chosen its moment. Some dismissed that phrasing as poetic indulgence, but the unease persisted. The object's behavior was beginning to feel orchestrated. The more data arrived, the more contradictions piled up. The comet's light curve showed minor, repeating fluctuations, gentle rises and falls that mirrored each other every few hours. A rotation pattern, perhaps? Yet when analysts plotted the changes against time, the rhythm didn't fit any rotational model. The intervals were too stable, the amplitudes too regular. At NASA's Goddard Space Flight Center, one astrophysicist likened it to the breathing of a star trapped in a comet. The phrase stuck. Other instruments joined the vigil. The Stereo A spacecraft, observing from a different angle, recorded strange asymmetries in the corona around the comet arcs of light that expanded and contracted as if driven by invisible magnetic tides. Some speculated that 3I Atlas's gas plume was interacting directly with the sun's solar wind, creating miniature auroras in the void. Others wondered if the object itself carried a residual magnetic field, fossilized from its birth in another stellar nursery. Whatever the cause, the effect was mesmerizing. Meanwhile, ground-based observatories in Hawaii and Chile captured the object's spectrum as it emerged from the sun's glare. The color had shifted again. The earlier azure glow was fading, replaced by a deeper indigo, a hue consistent with ionized nitrogen and cyanogen gas. That transformation suggested that the sun's heat had burned through the outer carbon layers, exposing volatile compounds buried deeper within. The comet was shedding its history one stratum at a time. But even this stratified story held mysteries. The ratio of these compounds implied chemical pathways that shouldn't exist in natural cometary evolution. They hinted at materials synthesized under pressures far higher than those found in protoplanetary disks. To generate such compounds naturally, the object would have had to form in an environment closer to a brown dwarf than a sun-like star. That possibility altered the tone of every conversation. If 3I Atlas had indeed originated near such a faint, massive star, it would mean the object's chemistry bore witness to conditions that predate the birth of our galaxy's modern structure, a messenger from the primordial Milky Way. For many, this was thrilling. For others, unnerving. In the conference halls of the International Astronomical Union, theories collided. Some researchers championed a purely natural explanation, exotic chemistry, rare but possible. Others whispered about anomalies that felt like signatures, regular patterns, threshold events, timing that seemed to obey hidden rules. A few even drew parallels to Oumuamua, the first interstellar visitor, whose acceleration could not be fully explained by outgassing alone. That earlier enigma had taught the scientific community to tread carefully between wonder and skepticism. Yet here was another, even more spectacular, rewriting the same lesson in fire. The shock of Perihelion was not just an observational milestone, it was a philosophical fracture. For the first time in decades, astrophysics itself trembled at the edge of the unknown. When 3I Atlas finally began to dim, retreating from the sun's light, it left in its wake a strange silence, as if the universe itself were catching its breath. Astronomers stared at their screens long after the data stream ended, knowing that what they had witnessed would be debated for generations. Something had awakened at Perihelion, something that defied explanation and mocked simplicity. It was not just the eruption of a comet, it was the reassertion of mystery in a cosmos we had dared to think we understood. And as the object faded into the cold beyond, one question lingered in every observatory, whispered as both awe and warning. What if this was only the beginning? The debate about what 3I Atlas truly was grew louder as its brightness faded. It was now outbound, retreating from the sun, but its enigma lingered in the laboratories, in sleepless minds replaying the data. The comet's silence, after its brief eruption, felt theatrical, like the final chord of a symphony that ends on a question. Yet, in that silence, another theory began to germinate, one that turned the object from a curiosity into a key. It began with the work of Susanne Felsner, an astrophysicist at Forschungszentrum Jülich in Germany. Her computer models of planet formation had long struggled with a puzzle known as the meter-size barrier. In protoplanetary disks, dust grains collide and grow until they reach roughly 1 meter in diameter. Beyond that, turbulence and drag tear them apart before they can grow larger. The physics of planet building stalled there, leaving an unanswered question: how do the tiny seeds of dust become planets at all? Felsner's simulations proposed an elegant solution. Perhaps the first planetary embryos were not formed within their parent disks at all. Perhaps they were imported, captured wanderers from interstellar space. Bodies like 3I Atlas, already massive enough to resist fragmentation, could slip through a young system's gravity, slow within its gaseous cradle, and become the scaffolding around which planets grew. Her idea transformed the conversation. Interstellar visitors were no longer just cosmic tourists, they were the seeds of worlds. If she was right, then objects like 3I Atlas were the unsung architects of creation, intermediaries between chaos and order, carrying with them the raw material of entire solar systems. The galaxy itself became a vast, recycling organism, stars birthing planets, planets shattering into comets, comets cast adrift to ignite the birth of new worlds elsewhere. And suddenly, the behavior of 3I Atlas took on a new resonance. Its eruption at Perihelion was no longer an isolated anomaly, but perhaps a signature of its role in this grander cycle. A seed reawakened by sunlight, releasing what it carried into the surrounding void, a chemical broadcast of its ancestry. Felsner's models showed that these interstellar seeds, once captured, could serve as gravitational nuclei around which dust and gas accreted. The process would bypass the meter-size barrier entirely. Within a few million years, a rogue interstellar traveler could transform into a planetary core. In this view, every star system, including our own, might owe its planets to the generosity of others. The poetic symmetry of the idea caught the imagination of both scientists and dreamers. If true, it meant that the atoms of Earth, of oceans, of life itself might trace their lineage to worlds long vanished, to foreign suns whose debris once drifted through space until captured by our forming system. When the researchers examined 3I Atlas's trajectory more closely, the numbers seemed to whisper of that same possibility. Its approach was shallow, its path almost planar, suggesting it had traveled across the galactic midplane where stellar nurseries bloom and die in cycles of cosmic renewal. It had passed through regions rich in interstellar dust, absorbing traces of them along the way. And now, at the end of its unimaginable voyage, it had briefly shared its essence with our own star, flaring one last time before vanishing. Felsner described such objects as planetary fossils, the unbuilt foundations of worlds that could have been. To her, the explosive brightening was not destruction but revelation, the outer layers, eroded by radiation, finally yielding their story under solar heat. "It is as if," she said, "we are watching a planet remember what it almost became." Her words resonated beyond science, because to think of 3I Atlas as a failed planet, a body that carried within it the potential for continents, oceans, perhaps even life, was to see the universe not as empty, but as brimming with unfinished creation. Other theorists took her idea further. Perhaps these interstellar embryos were intended not by intelligence, but by nature's design. If every system expels debris during its birth, and if that debris becomes the seed of another, then the galaxy is self-fertilizing, a continuous lineage of matter giving rise to worlds, in a cycle without beginning or end. In that light, 3I Atlas was not an anomaly at all, it was proof of cosmic continuity, a link in the endless chain of planetary genesis. Still, one could not escape the emotional gravity of the thought. This object, older than the Sun, had wandered unclaimed for billions of years, its purpose unrealized, its potential never fulfilled. And now, in its encounter with our star, it gave everything it had left, its gases, its light, its secrets, to a universe that had already moved on. Perhaps, in another system, another time, another star's warmth might have captured it. Perhaps it would have accreted dust and rock, birthed a moon, cradled oceans, dreamed of eyes that would one day look up at its sky. But fate had made it a drifter. And in that drifter's flare, humanity saw a reflection of itself, another child of the cosmos, wandering through immensity, bearing within it the memory of lost origins and the potential for worlds yet to come. It was not a comet, not merely a visitor. It was a reminder, a cosmic embryo that never found its home, still teaching those who watch it that even in failure there is purpose, and even in silence creation speaks. The further 3I Atlas drifted from the Sun, the clearer its true magnitude became, not in size, but in time. Its velocity and trajectory implied something staggering. This object had been traveling for up to 12 billion years. That would make it older than the Earth, older than the Sun itself, older even than most of the stars we can see in our night sky. To speak of such age is to step outside the comfort of human language. Numbers lose their texture. 12 billion years is not merely duration, it is transformation measured in epochs. In that span, entire generations of galaxies have been born and consumed by the darkness. Civilizations of stars have burned, collapsed, and risen anew. The Milky Way itself was a different shape when 3I Atlas began its journey. It may have been ejected from a young, unstable system long before our solar nebula coalesced, a fragment cast outward by the gravitational chaos of newborn worlds. Or perhaps it formed in the space between stars, condensing from a drifting cloud of primordial gas at the galaxy's edge, untouched by any sunday. Whatever its origin, the object had survived, a voyage no human artifact could ever endure. It had crossed regions of interstellar radiation strong enough to vaporize spacecraft. It had slipped past supernova shockwaves, magnetic storms, and fields of debris, maintaining its integrity like an immortal stone adrift in eternity. Its endurance defied probability. Statistical models of interstellar debris predict that few such objects should survive more than a few billion years before fragmentation or erosion reduce them to dust. Yet 3I Atlas remained whole, as though protected by its own impossible resilience. The irradiated crust described by Maggiolo's team now appeared not as a byproduct, but as a blessing armor forged in radiation, a self-sealing carapace that had allowed it to cross the eons intact. The thought inspired reverence. A body born before our sun had lived long enough to pass through its light, and in doing so, it became one of the oldest physical things ever observed directly by humanity. When the James Webb Space Telescope measured the composition of its gases, it found isotopic ratios slightly skewed toward heavier forms of hydrogen and oxygen. That subtle fingerprint suggested ancient molecular origins matter forged in an environment where the universe itself was still young, rich with cosmic rays and high-energy interactions. In its atoms, scientists saw the story of a younger cosmos, a time when the first stars were still sowing the periodic table, when carbon and oxygen were rare, when galaxies themselves were infants. 3I Atlas was a survivor from that raw age, carrying those primordial signatures unchanged across time. Astronomers compared it to a message in a bottle from the cosmic dawn. The metaphor fit too well. When telescopes plotted its trajectory, they found it followed a nearly straight, planar path relative to the galactic disk, an improbably flat motion suggesting that it had not been significantly perturbed by gravitational encounters. It had sailed through the galaxy like an arrow, undisturbed, on a mission with no destination. That serenity seemed almost eerie. Most long-traveling bodies spin chaotically, their paths bent by the influence of stars and gas clouds. But 3I Atlas moved as though guided by a calm hand, its orbit slicing through the solar system at a fixed angle of 43 degrees to the ecliptic, steady and unwavering. "This is not a wanderer," one researcher remarked. "It's a pilgrim." The idea resonated deeply. In every respect, its age, its trajectory, its composure, the object felt purposeful. It was as if, across cosmic time, 3I Atlas had never forgotten its direction. Some astronomers began to speculate that its motion was not random at all, but part of a broader pattern. Statistical analyses of interstellar object trajectories, Oumuamua in 2017, Borisov in 2019, and now 3I Atlas suggested subtle alignments, a clustering of approach vectors pointing roughly toward the constellation Lyra. The sample size was small, yet tantalizing. Could these objects share a common origin? Could there be a region of the galaxy, perhaps near an ancient stellar association, that serves as the cradle or graveyard of such travelers? If so, then 3I Atlas was not alone. It was one messenger among many, part of a quiet migration of debris, or perhaps relics, from a lost stellar civilization of matter itself. The implications rippled outward, because if this interstellar flow of objects is continuous, then every star, including ours, both gives and receives material in an endless galactic exchange. Matter, chemistry, memory all drifting between systems in a slow circulation of existence. Somewhere in its dark, cold heart, 3I Atlas might still carry unaltered ices from the nebula of its birth. That ice could contain isotopic ratios unlike any seen in our solar system, perhaps even organic molecules, unique to its original chemistry. But those secrets would remain locked forever. The object was receding at over 130,000 miles per hour, too far now for any probe to reach. Humanity would never touch it. And yet, the thought that such a relic had passed through our neighborhood, however briefly, changed everything. It was proof that the galaxy is not static. It breathes, it exchanges, it remembers. Every fragment cast into space may one day become a visitor to another sun, a temporary guest in another civilization's sky. In that sense, 3I Atlas was more than a comet. It was a traveler carrying the ashes of one creation to the doorstep of another. Its journey was a bridge between epochs, a tangible link between the first stars and the latest generation of observers gazing at them. The universe, through this one solitary object, had shown us that time itself is a continuum of matter, that nothing born under a star is ever truly lost. It simply travels onward, awaiting the next light to reveal it again. And so, as 3I Atlas dwindled into invisibility, fading beyond the reach of telescopes, astronomers found themselves looking not at its absence, but at their own reflection within its story. We too are made of remnants older than our Sunday. We too are interstellar matter awakened by light. By late November 2025, as the last traces of 3I Atlas disappeared into the darkness beyond Mercury's orbit, the questions it raised had begun to unravel the tidy boundaries of conventional science. Some mysteries, like the absence of dust or the synchronized eruption at Perihelion, still invited natural explanations, but others lingered in a zone that made scientists uneasy. That unease had a name: Avi Loeb. Loeb, the former chair of Harvard's astronomy department, had already become a controversial figure during the debate over Oumuamua, the first interstellar object ever detected. Back in 2017, he had argued that its acceleration and shape might not be purely natural, provocatively suggesting it could have been an artificial probe, perhaps the drifting relic of an extinct civilization. His insistence on that possibility had divided the scientific community, drawing both admiration for his courage and criticism for his audacity. Now, with 3I Atlas, Loeb resurfaced. The object's anomalies, he claimed, demanded transparency. In a letter to NASA and the European Space Agency, he called for the full public release of all observation data, optical, spectrographic, and radio, so that independent researchers could analyze it without institutional filters. "The universe doesn't hide its truths," he wrote. "Only institutions do." His appeal struck a nerve. The story had already reached mainstream headlines, capturing the public's imagination. Words like interstellar, explosion, and unexplained were too cinematic to resist. But Loeb's request added something else: tension. It was no longer just about data, it was about what humanity was willing to consider possible. At the heart of his argument lay a simple principle: when confronted with unprecedented phenomena, science should remain open to all explanations until the evidence excludes them. That included, he insisted, the possibility that some interstellar objects might be technological in origin. Extraordinary claims require extraordinary evidence, he admitted, but dismissing the extraordinary before looking for the evidence that's not science, that's faith in ignorance. To many in the astronomical establishment, it sounded like a provocation, but Loeb's reasoning was difficult to dismiss outright. After all, 3I Atlas was the third interstellar object ever found, and each had defied expectations. Oumuamua had shown inexplicable acceleration. Borisov had been surprisingly pristine for a traveler from another star. And now 3I Atlas had erupted, glowed, and then vanished with behavior that mocked every model. 3 objects, 3 riddles. In the quiet of conference halls, some scientists whispered what Loeb said aloud. What if they aren't all the same kind of thing? Could interstellar space hold both natural wanderers and something else, constructs, relics, derelicts, adrift between suns? The suggestion hovered in the air, unspoken in papers but present in every discussion. Even those who dismissed it entirely could not erase the discomfort it provoked. Because beneath Loeb's speculation lay a question that refused to die. What does natural even mean when you look across 12 billion years of cosmic evolution? Physics knows no distinction between the artificial and the natural. A probe built by a civilization is as much a product of the universe as a comet born in a protoplanetary disk. If intelligence is an emergent property of matter, then so too are its creations. And so, if one day we were to discover that something drifting between the stars was built not by us, but by another mind, would that be alien to nature or simply another branch of its expression? For Loeb, the answer was obvious. Nature includes intelligence, and until we've ruled it out, every anomaly deserves to be examined without prejudice. NASA, cautious as always, responded that all data from 3I Atlas would indeed be made available through the planetary data system following review and calibration, but the damage or the awakening had been done. For the first time since Oumuamua, the global conversation about interstellar visitors had broken free of the scientific journals and entered the realm of cultural imagination. Late-night talk shows speculated about alien probes. Podcasts invoked Arthur C. Clarke. Documentaries drafted scripts before the data was even released. And somewhere between those extremes, between cynicism and wonder, lay the truth. Humanity was confronting, once again, its own humility. Because regardless of what 3I Atlas turned out to be, it had forced open the same philosophical wound that Oumuamua had left raw. The cosmos is not ours to predict. It is stranger, older, and more inventive than our models. Each new anomaly is not a threat to science, but a test of whether science is brave enough to follow curiosity wherever it leads. Loeb's voice became the chorus for that bravery, or its rebellion. If we find nothing extraordinary, he said, then we have still learned something precious that we looked, and that looking itself is what defines us. Even his detractors could not deny that sentiment, because behind the debate over data release, over hypotheses and funding and credibility, was a quiet, universal yearning to know whether the cosmos is speaking to us. As December began, Loeb's call echoed through research networks. Independent astronomers began reprocessing light curves and spectra, searching for patterns missed in the official reports. A few claimed to detect faint periodic modulations in the comet's tail brightness, barely significant, likely noise. Yet, the very act of looking, of questioning, felt electric. Across the scientific community, 3I Atlas had reignited something that had dimmed under decades of certainty: the willingness to wonder. The data would, in time, tell its story. But until then, Loeb's challenge remained like a refrain: do not look away from the strange. Do not simplify the unknown. Because sometimes, he reminded us, the universe tests us not with answers, but with how we respond to questions too vast for comfort. By the start of December, as the data poured into the archives and the heat of debate intensified, the world of science found itself quietly divided. It wasn't just about the comet anymore, it was about the boundaries of belief. What should science allow itself to imagine? Where does skepticism end and fear of wonder begin? The camps formed quickly. On one side were those who saw 3I Atlas as a marvel of natural complexity, a fusion of chemistry, thermodynamics, and radiation physics, pushed to its cosmic limit. To them, the explosions, the precision, the color, all of it was extraordinary but explainable. Nature, they reminded their colleagues, is always stranger than imagination. On the other side stood the quiet few who hesitated before the word explainable. They had seen the same data: the symmetric flare at Perihelion, the absence of dust, the perfect timing. Each anomaly alone could be dismissed. Together, they felt orchestrated. The schism was subtle but growing. Every conference call, every preprint, every hallway conversation seemed to circle the same invisible line between the comfort of the known and the gravity of possibility. In closed-door meetings, data analysts presented spectral sequences that defied noise filtering, faint modulations in the ultraviolet flux too weak to publish, too regular to ignore. Could these be the product of rotation? Or were they something else, periodic fluctuations that hinted at internal rhythm rather than surface geometry? Periodic, but not rotational, one researcher murmured in disbelief, like a heartbeat. The phrase took hold, the heartbeat of 3I Atlas. No one dared to publish it, but it lingered in the quiet margins of private memos and email threads. Meanwhile, the official narrative stayed grounded. NASA's preliminary report, released in December, framed the event as a non-linear sublimation cascade, a complex but natural process where heat-triggered phase transitions release trapped volatiles in sudden, synchronized bursts. In other words, ice behaving strangely, but still ice. It was, in every sense, the safe answer. Yet the data refused to stay safe. Independent analysis from the University of Tokyo suggested that the energy released during the flare exceeded what could be accounted for by water and carbon dioxide alone. There was missing mass energy with no obvious source. Some proposed chemical recombination reactions within the irradiated crust. Others wondered if deeper volatiles, ammonia, methane clathrates had contributed. But none could model the precise timing, the clockwork execution of the event. The tone of the debate turned philosophical. Was coincidence enough? Was it arrogance to assume the universe does not produce order unless guided by will? For centuries, science had advanced by refusing to anthropomorphize nature. But the longer the data was examined, the more it seemed that nature itself was performing an imitation of intent. Some began to see 3I Atlas as a mirror to our own expectations, a lesson in humility. If its behavior resembled design, perhaps that said less about the comet and more about our human tendency to project pattern onto the unknown. Others weren't so sure. A small group of astrophysicists, inspired by Loeb's call for openness, began reanalyzing radio data collected by the Stereo and Parker Solar Probe missions during Perihelion. Buried within the static of the solar wind, they found transient spikes in the radio spectrum, centered around narrow frequency bands. These were likely artifacts, reflections of solar interference, but they carried a haunting symmetry. Repeating bursts, equal intervals, fading after precisely 84 seconds. Noise, said the skeptics. Coincidence, said the optimists. But for those caught in the middle, the distinction blurred. For the first time, astronomers began to realize that even if 3I Atlas was purely natural, its behavior was still beyond full comprehension. And that truth, its unfathomable naturalness, was almost more unsettling than any alternative. After all, a designed object has a purpose, a logic. But a natural one, capable of mimicking intention, implies that the universe itself may harbor an intelligence deeper than mind, an order that arises without thought, yet manifests with precision that mocks the concept of chaos. That notion seeped into the community like quiet poetry, that the cosmos does not need architects to appear designed. Its beauty is algorithm enough. The discussion began to change tone. The combative edge softened into wonder. Physicists compared 3I Atlas to Oumuamua, noting that in both cases, nature had crafted phenomena that behaved as though engineered: the sleekness of trajectory, the control of acceleration, the delicacy of timing. To an ancient mind, ours included, they would seem deliberate. To the cosmos, they were simply consequence. Somewhere between data and awe, between mathematics and metaphor, the meaning of the event began to shift. Perhaps, said a paper quietly circulating through research circles, we are not being asked to choose between the natural and the unnatural, but to understand that both emerge from the same origin. In that moment, science rediscovered its older self, the part that once looked at the heavens not as a mechanism to dissect, but as a mystery to honor. When Avi Loeb read that line, he smiled, not because it vindicated his suspicions, but because it reminded him of why he had started this quest in the first place. The danger, he once said, is not that we will believe too much, but that we will wonder too little. And so, even as the debates grew quieter, even as the object itself receded beyond our reach, a quiet truth settled over the scientific world. The mystery of 3I Atlas had done what no discovery had in decades. It had made the cosmos feel alive again. By January 2026, the comet was gone, just a line of coordinates on star charts, a memory fading into the heliosphere's haze, yet its absence felt heavier than its presence had been. For months, 3I Atlas had commanded the world's attention, forcing physicists, poets, and dreamers alike to look upward and reconsider what the universe is capable of. Now, it had returned to the darkness, leaving only data, disagreements, and a strange ache, a longing for something we had barely known and would never see again. Across observatories, telescopes turned away, their sensors cooling to silence, but the conversation it had ignited refused to end. Every research lab that had touched its light was still haunted by it. On paper, the story was supposed to be finished. The comet's activity had declined, its spectrum dimmed, its water production dropped to nearly zero. There were no new eruptions, no signals, no more surprises. And yet the data analysts noticed something subtle in the post-perihelion readings, an asymmetry. When plotted against time, the decline in brightness did not mirror the rise. It fell too slowly, as though energy was still bleeding from within. Even as it drifted away from the sun, losing the warmth that had awakened it, 3I Atlas seemed reluctant to fade. What if it's still burning from the inside? One scientist whispered during a late-night data review. No one could answer. That lingering glow, faint but measurable, became the final riddle. Some attributed it to residual sublimation, a slow release of volatiles trapped beneath the irradiated crust. Others speculated about internal chemistry, exothermic reactions continuing deep in the nucleus. But for the more reflective minds among them, it felt symbolic. The comet was doing what every discovery does, fading but never fully extinguishing. It had changed how people thought about the interstellar void. Before Oumuamua and Borisov, the space between stars had seemed empty, a sterile gulf. Now, that illusion was gone. The galaxy, it turned out, was full of wanderers, fragments of shattered systems, frozen oceans, planetary embryos, even possible relics all drifting in silence, each carrying stories of other skies. To think of them that way was humbling. It meant our solar system was not a closed stage, but part of an ongoing cosmic dialogue, a conversation in which materials and perhaps memories were exchanged across unimaginable distances. A new generation of scientists began to speak of interstellar ecology. The phrase sounded poetic, but it had teeth. If objects like 3I Atlas are common, then star systems are not isolated laboratories of creation. They are participants in a galactic cycle. Every system gives and receives matter, sharing chemistry, structure, even potential. In that vision, the Milky Way itself becomes alive, not metaphorically, but dynamically. A self-sustaining organism whose bloodstream is made of drifting comets. Meanwhile, philosophers and theologians found their own reflections in the data. For them, 3I Atlas embodied the paradox of existence, a thing so ancient and vast that it dwarfed meaning, yet so precise and fleeting that it demanded it. If a single object can travel for 12 billion years and still flare to life beside our sun, what else, they wondered, might endure across time and darkness? Humanity's telescopes may have lost the comet, but its memory lingered in human imagination. Artists painted it not as a ball of ice, but as a pilgrim, a shard of cosmic memory ablaze with revelation. Writers compared its perihelion explosion to a heartbeat, a resurrection, the brief exhalation of something that had waited too long to speak. And in the scientific literature, something else shifted. Papers once written with clinical detachment now carried undertones of reverence. The object challenges our models, one abstract began, and invites us to rethink the temporal scale of cosmic evolution. Another concluded simply, we have witnessed a fragment of the galaxy remembering itself. For the first time in decades, data and poetry shared the same language. The telescopes, still watching JWST, Hubble, and a few ground-based giants in Chile and Hawaii, continued to report dim readings, nothing more than faint infrared traces. Yet every photon felt sacred. They were the final crumbs of light from a messenger that had crossed the universe to reach us. Somewhere in its dark retreat, the comet was cooling again, its surface refreezing, its internal chemistry slowing to a standstill, but perhaps not forever. In a billion years, it may drift past another star, another Sunday, and there, the warmth will reach it once more. It will awaken, as it did here, shedding vapor and light, writing another story across another sky. Perhaps another civilization, distant and unimagined, will look upward and wonder at the same questions we do now. And perhaps they too will name it. Because every traveler from the interstellar dark carries within it something that transcends science, a reminder that the universe is both ancient and newborn, silent yet articulate, indifferent yet intimate. 3I Atlas, in its passing, proved that even the coldest fragment of space can ignite meaning in the minds that behold it. We will never see it again, but every time our species looks toward the stars and wonders what drifts among them, some quiet part of that ancient object will stir again in memory, in imagination, in the shared recognition that the unknown is not empty. It is alive. Now, the sky is empty again. The sun burns quietly in its familiar solitude, and the senses that once strained to follow the flicker of 3I Atlas have turned elsewhere to other stars, other promises. But for those who watched it, those who measured its pulse and traced its breath across the void, something fundamental has shifted. The silence it left behind feels different. It is no longer an absence. It is an echo. What, in the end, did this visitor reveal? Nothing conclusive, nothing that fits neatly into equations or models. The data remains a tapestry of contradictions, a comet that exploded without fragmenting, that burned blue in defiance of physics, that possessed no dust and yet glowed brighter than logic allows. But perhaps that is the point. The universe had not come to give us answers, it had come to remind us that questions themselves are sacred. In the weeks that followed its departure, scientists continued to pass the fragments of information, refining numbers, adjusting models, releasing papers whose titles grew ever more tentative. Anomalous brightening in an interstellar object, preliminary hypotheses on radiation, processed ices. Every study, however rigorous, seemed to circle the same void at its center, that there are still laws of the cosmos we do not know, patterns too vast for our instruments to read. But something subtler emerged amid those equations, a renewed humility. For too long, humanity had assumed that mystery was the mark of ignorance. Yet 3I Atlas had shown that mystery is also the mark of depth, the signature of a universe that will always remain greater than the minds that study it. Avi Loeb's call for transparency still echoes through the halls of research agencies, not because of conspiracy or hidden knowledge, but because of a deeper conviction. that the search for truth must remain open, unguarded, collaborative. Every photon, every spectrum, every anomaly belongs to all of us. The universe is a shared inheritance, and its stories are written for every eye that dares to look. As the interstellar object drifts farther into the dark beyond Mars, beyond Jupiter, beyond even the reach of the sun's warmth, it carries with it more than molecules and radiation scars. It carries a fragment of human curiosity. For a few short months, its light fell upon us, and we responded not with fear, but with wonder. And that wonder, that quiet ache to understand, is what will follow it into the dark. For the poets, 3I Atlas will be remembered as a messenger, a frozen pilgrim that crossed billions of years to whisper a single, untranslatable truth. For the scientists, it will remain a dataset complex, imperfect, eternal in its incompleteness. And for the rest of humanity, it will become what every great cosmic encounter becomes, a story, a reminder that even in the infinite, we find connection. Because perhaps that was the true revelation, not what 3I Atlas was, but what it did to us. It made us look again. It made us remember that the sky is not a ceiling, but a door, that behind the veil of light and time, there are still travelers moving in silence, carrying histories older than our world. It is gone now, vanishing into the interstellar dark from which it came, leaving us with only a lingering thought that somewhere, in that darkness, other suns are rising, other worlds are turning, and other minds may be watching their own wanderers pass, wondering if anyone, anywhere, is watching too. And perhaps that is how the universe speaks. Not in words or signs, but in brief encounters, moments when the unknown brushes against our understanding, reminding us that we are part of something immeasurable. As night falls over the observatories and the telescopes power down, the last recorded light of 3I Atlas remains stored in data servers, a faint pattern of numbers light that began its journey billions of years before Earth even existed and ended in our machines, our eyes, our awe. In that way, the story continues. The traveler moves on, and we, who have glimpsed it, are changed. And now, let the lights fade. The screens dim. The hum of telescopes falls silent. The storm of analysis softens into quiet reflection. Out there, in the black between stars, 3I Atlas sails on, smaller now than the memory it left behind, colder than any truth we can measure. It carries no message, no intent, only existence itself, and that is enough. Imagine it, a shard of another dawn, gliding through emptiness that has no edge, no eyes to see it, no instruments to chart it, only darkness, and the whisper of its own slow rotation. Once it burned before our sun, and for a brief moment, the ancient and the present touched. Then it moved on, as all things must. The data will fade, the debates will quiet, but the feeling will remain, the stillness that follows revelation, the knowledge that mystery endures. Somewhere beyond the heliopause, its irradiated crust gleams faintly in the starlight of no particular system, an ember adrift in eternity. Perhaps it will wander for another billion years, untouched, unseen, until one day another star's warmth wakes it again. Another flare, another sky, another species perhaps, watching in wonder and asking the same impossible questions we asked here. And so the universe goes on, a cycle of light and distance, of awakening and silence. We will not see it again, but that doesn't matter. We have seen enough to know that we are part of a story far older than ourselves, a story written in motion, told in light. Sleep now, little traveler. Carry our wonder with you. Sweet dreams,